Hi, welcome to Theorem. In this lesson, we will learn the first sign of congruent triangles. In most of the geometry problems, the problem itself will not state that two triangles given in that problem are congruent. We need to understand that those two triangles are congruent by using the given information in the problem. So those given information are like clues from which we understand that triangles are congruent. Those clues or the information from which we understand that two triangles are congruent, I will call them as signs of congruent triangles. So there are mainly three signs to understand that two triangles are congruent. In this lesson, we are learning the first sign of congruent triangles. So let's see the theorem. This is the third theorem of our plane geometry lessons. Theorem 3 says if if two sides and the angle between them of one triangle are respectively equal to two sides and the angle between them of a second triangle, then these two triangles are congruent. If you saw next to first sign of congruent triangles in my title, I put three letters here, SAS. Those three letters, they refer to side, angle, side. Now, when you look at the theorem, these three letters will make more sense. Side angle side, SAS, side angle side, will be uh, will help us in the future to refer to first sign of congruent triangles. So when I see for two triangles, when I see these information, I will quickly say that triangles in a geometry problem are congruent by side angle side. So I will quickly refer to this theorem, which I called here as first sign of congruent triangles. So why is it side angle side? Because that's what is given about these two triangles. So if two sides and angle between them in one triangle are equal to two sides and angle between them in a second triangle, so the given information is side angle side, two sides and angle between them in two triangles. So if so, then these two triangles are congruent. One more thing I want you to realize that the theorem is written as a conditional clause. If P, then Q, right? So whatever you see between if and then, in between if and then, that's P, that's the condition or the given information in our proposition. And whatever you see after then, it's Q, which is the proposition we need to prove, right? So if the condition P is satisfied, I must show that the proposition Q is true, right? So let's start our proof after all these explanations. So I quickly drew two triangles here. I made them ready not to lose time. You see that we have two triangles. Let's quickly label those two triangles, the vertices of our triangles. Let's say that this is the triangle ABC, and let's say that this second triangle is the triangle A1, B1, C1. Okay, and what I see about these two triangles is uh, the side AB of the first triangle is equal to the side A1B1 of the second triangle. Side AC of the first triangle equals side A1C1 of the second triangle. And angle between these two sides, angle A of the first triangle, is equal to the angle between these two sides, angle A1 of the second triangle. Okay? So that's the given information. I'm quickly grouping these letters and my triangles so that they move together. Okay, and I want to quickly write the given information once more. AB is equal to A1 B1, angle A equals angle A1. This is given, right? That's the condition satisfied. I'm assuming that we have this information for these two triangles. And lastly, angle, side AC is equal to side A1 C1 of the second triangle. Okay, so how do we prove that these two triangles are congruent? I will use the definition of congruent triangles. It was we saw that definition in plane geometry lesson 7. I quickly remind you, two triangles are called congruent triangles if they perfectly overlap when you put one of them on the other. So when we have two congruent triangles, the vertices of these two triangles, sides of these two triangles, and angles of these two triangles, respectively, right? They perfectly coincide in pairs, or we say respectively. Okay, so that's I will use the definition. I will use the definition to prove that these two triangles are congruent. So what I will do is I will put the second triangle, for example, onto the first one, and I will check if their sides, angles, vertices perfectly overlap, okay, in pairs. So let's do it. I'm taking my second triangle. So sorry, these two triangles are grouped all together. Let me check. Yeah, these are grouped all together. What about this one? I think we have a problem here. Yeah, I'm quickly grouping these, but I don't want to group this one there. Okay, I think we are good now. Okay, let's do it. I'm moving this triangle. I will move it. I will drag it and drop onto the first triangle, and I will see if the vertices, sides, and angles perfectly overlap. Okay, so I'm moving the triangle, but I see that I need to rotate my triangle a little, right? I need to rotate. So I'm rotating my triangle a little, and I'm moving it, putting it onto the first one. So I see that we need to rotate it some more. Let's put C1 on C, and then I will rotate it some more. Okay, let's check once more. Okay, I think that makes sense to you, right? So when I move triangle A1, B1, C1 and put it onto the first triangle, let's start with vertex A. First, I want to overlap the vertices A and A1. So let's start. I will write now. When I put triangle A1, B1, C1 on the triangle ABC such that the vertices A and A1 overlap, what do I see? Since angle A and angle A1 are equal, I can understand that the side AB of the first triangle and the side A1B1, remember, the corresponding side of the second triangle is A1B1, they fall onto each other, right? So I'm writing it. When I put it this way, since angle A is equal to angle A1, the side AB the sides AB and A1, B1 fall onto each other. Actually, A1, B1 falls onto AB. Let me write it that way, I apologize. The side A1, B1 falls onto the side AB. But since the length of AB and A1, B1 are equal, it means that vertices B and B1 perfectly overlap. Make sense? So, since AB is equal to A1, B1, the vertices B and B1 perfectly overlap. Similarly, since the angles A and A1 are equal, the side A1C1 of the second triangle also falls onto the side AC of the first triangle. Similarly, since angle A is equal to angle A1, the side A1C1 of the second triangle falls onto the side AC of the first triangle. And since the length of A1 and the length of AC is equal to the length of A1C1, the vertices C and C1 also perfectly overlap. And since the length of AC is equal to the length of A1C1, the vertices C and C1 perfectly coincide or overlap. I wrote overlap here, I wrote coincide here. Doesn't matter. They mean the same thing, right? So what do I see now? I see that vertices A, B, vertices A and A1, sorry, B and B1, C and C1, they perfectly overlap, and that's why the sides AB and A1, B1, the sides AC and A1, C1, the sides BC and B1, C1, they also perfectly overlap. Angle A and angle A1, angle B and angle B1, angle C and angle C1, they also perfectly overlap. Make sense? So this means, let me write it this way, since all three vertices A, B, and C of triangle ABC perfectly coincide with all three vertices of the second triangle, all three vertices A1, B1, C1, and C1 of the second triangle A1, B1, C1. The sides the sides AB and A1B1, AC and A1C1, BC and B1C1, and the angles A and A1, the angles B and B1, the angles C and C1 also perfectly overlap or coincide. Okay, let's write overlap once more. That's why triangle ABC is congruent to the triangle A1, B1, C1. So that's the end of our proof. So we saw that when two sides and the angle between them in one triangle are respectively equal to two sides and angle between them of a second triangle, when I put the second triangle onto the first, I see that all three vertices, all three sides, all three angles respectively uh, and perfectly overlap and coincide, and that's why we understand that those two triangles are congruent triangles. So our first sign of congruent triangles, which is side angle side, has been proven perfectly, I believe. I hope that it's understandable. Thank you so much. Stay with us. Video became a little long. Forgive me, please. Thank you. Please subscribe and follow my channel. See you in the next videos. Bye.